afternoon. I'm Daniel Hobbs. I've got about 30 years in using innovation to help technology, to help transport become more efficient, and recently been focusing very much on the energy transition. And today we're going to talk about Hydrogen and Innovation Initiative, which is a cross-Catapult initiative to try and support the whole transition and to hydrogen, whilst supporting the growth of the UK economy, so supply chains within the UK. So we've got a great panel here to talk about the demonstrations and some of the challenges that we're drawing in. So everyone can introduce himself individually. So if you'd start off with Chris, and explain why hydrogen is an exciting opportunity.
Yeah, so hello everyone. My name's Chris Games and I'm head of application engineering at ULEMCo. So just for you who don't know, ULEMCo an SME based out of Liverpool, and we specialise in the integration of hydrogen systems onto vehicles, primarily utility vehicles and HGVs, things like that. Where we see a really good opportunity for hydrogen is in applications that have extremely high power demands, in potentially rural areas where you don't have, great grid capability. But also if you think about the likes of response vehicles and things like that, where you can't really afford to have any downtime, charging time. But also we see hydrogen being a big part of the decarbonisation plan in being able to provide redundancy as well. So as I mentioned, the likes of first response vehicles at the moment, if we ever have a blackout, a power cut, you've got stockpiles of diesel and petrol that the police, fire brigade and ambulance can use. Although it's possible, it's quite hard to stockpile and keep a load of electrical energy stored to be able to charge these vehicles, where it's much more easy and feasible to do so with hydrogen. And that's where we see it playing a part in the whole role of decarbonisation.
Great, thanks Chris. And Lahiru, from the aviation perspective.
Yeah, hi everybody. My name is Lahiru Ranasinghe and I work for easyJet. And for us, we really think that hydrogen is the future for short-haul aviation, at least within the 2050 timescales. Absolutely, for anything bigger than that, it does work. It does work as well. And the reason why we believe this is because, first, the obvious environmental benefits, but also in a world where we are having to decarbonize the whole of aviation, and we're having to do that through sustainable aviation fuels. We recognize that we're only going to be able to do a portion of that, less than half of that, with sustainable biomass, and therefore there's going to be a requirement for a lot of power to liquid, putting a lot of strain and demand on the upstream energy production. So we see hydrogen as a really sensible way to de-risk that decarbonization process for us. And easyJet themselves, as an airline, this is not typically an area in which we operate in terms of the technology development and scaling up. We usually go to Airbus and pay them a few bob and get our planes. But as we have this extremely compressed timeline to get this industry to net zero, and you can see this right across the industry, all elements of the industry really starting to get together and collaborate to put our weight behind making this transition happen.
Rebecca, what would you say?
So I'm Rebecca Advani. I'm a lead systems engineer at the Connected Places Catapult. I've got a background in zero-emission transport in different domains, road and some in aviation and maritime. And I am now leading the Connected Places Catapult's involvement in the Hydrogen Innovation Initiative. So I see hydrogen as an opportunity to decarbonise things that are hard to electrify or impossible to electrify. So we're looking beyond transport applications at it's hydrogen needed for fertiliser and other chemicals, and for long-term energy storage to support the grid as we go to more renewables, and for high temperature processes in heavy industry. So there's a lot of applications, as well as a lot of different transport ones that we see. And we're trying to work out how those industries also can work together in this transition.
Sergey, why is hydrogen exciting for you?
So for me and for ZeroAvia, it is, by the way, ZeroAvia is a manufacturer of engines for airplanes, and we believe that hydrogen is, frankly, the only scalable solution to solve the environmental issues in aviation. And I echo easyJet. It's the use of sustainable aviation fuels is super important in the short term and medium time perspective, especially for the long haul operations. But we are starting, we as a company, we are starting with the small aircraft and increasing the size and the length of the mission. And we see that with hydrogen, actually, we can solve not only the small aircraft, we can introduce not only the small aircraft, now we are working on the 19-seat aircraft, and in the next 2 years we will introduce this in the commercial operations. And in about 4 years we will have a larger turboprop already, which can carry about 50 to 60 passengers. And in the next 10 years we can see the roadmap where we can fly about 100 passengers already on the missions which are relevant in current passengers operations. And then, of course, together with the aircraft OEMs, again, given that we are engine manufacturers, we are working on how to actually make the biggest impact in terms of the environmental reduction of the environmental footprint. That is starting to work on the narrow bodies and then beyond. And the 2050 for us, it's actually realistically optimistic.
Yeah, good. Lahiru, what would you say the barriers are to using hydrogen in an aerospace environment now?
Ooh. How long do you have?
We've got a few minutes.
So I think one of the biggest things is going to be actually to do with the storage and the delivery of it because of the volumetric energy density. If we are going to be able to do anything useful with it, we have to be able to store the hydrogen as a cryogenic liquid. Now we have seen through the work that ZeroAvia has done, as well as work we are doing with Rolls-Royce and others, that the propulsion system part of it works. It works, and it is, while there are plenty of challenges, that really the big kahuna there is how do you store this at minus 250 degrees Celsius and then deliver it to the engine as a gas. That is the biggest part of it. The speaker who was up before was talking about the regulatory environment as well. And this is a huge change we're talking about, because for 115 years we've been running on hydrocarbon fuels. So changing to hydrogen, which is not very well known in the transport industry as it is, it requires a huge amount of change from a regulatory perspective and also from a cultural perspective to start understanding what it is, understanding how we use it. Now, those are a lot of challenges I've talked about, but the positives are that we are already starting to see those come in, because our colleagues here have been doing plenty of work with hydrogen for starters, but we have also started working on the ground because we have seen that there's an opportunity for hydrogen with ground support equipment, but also that is the best and easiest way for us to start the process of understanding the safety aspects of it and bringing the aviation-specific regulations into play, because the moment you cross that barrier from land side to air side, it becomes a completely different planet in terms of the regulatory environment. So we have started that process because we think it's absolutely critical for us to start right now so that we can build up to the point that we can operate the ZeroAvia aircraft in commercial airports, and of course moving towards the larger aircraft eventually.
Chris, does the same sort of regulatory environment apply where you're working?
Yeah, I'd say that in transport it's a little bit further ahead. So obviously there are a lot of uses of fuel cell powered vehicles. I mean, the Toyota Mirai, I think they've already got 2 or 3 generations of that. Obviously not readily available in the UK just purely because of the lack of infrastructure, but you do see a few knocking around. But one of the things that you mentioned about the knowledge and the acceptance, what we do as part of our conversions of any vehicles, anything that we supply to our customers, we make sure that we include training, whether that's basic workshop training, what to look out for, and just general hydrogen training as well. But we also do something that's quite specific to fire and rescue services and the first responders as well. And what I've noticed is everyone sort of, they think they hear hydrogen, they think bomb, and then after you go through the safety aspects of the system, because these are systems that have been developed sort of in the past 5 to 10 years, they are inherently safe and they'll go through a lot of scrutiny, and when you explain all the safety systems that are involved, 99% of them just go, oh, okay, and they've got no more questions. But it is a case of just trying to sort of explain what it's all about and just give them a little bit of trust in the fuel.
Rebecca, do you want to add to that?
Yeah, I was just thinking about those challenges. There are some, while the airside environment has its own regulations, there's still a lot of learnings that if they are, especially if it is safe and regulated enough for the airside environment, that then could translate to other areas, and a lot of the work that you've been doing on training and other things as well that could, like we're looking at the use of hydrogen at ports, for example, which is quite new to a lot of them, but we're trying to ensure that that knowledge can be shared and translated across the sectors, because they potentially haven't had to learn as much from each other in other, now that we know what we're doing with a lot of fuels. But this is something where hopefully we can make that more efficient, and again, if we can do that in the UK, it can give certain UK groups that advantage that we are sharing knowledge and therefore being able to progress a bit faster.
Sergey, in terms of demonstrations, are they a key part of this process?
So, in general, answering this question and the question about the barriers or the risks, I think that we are talking about 3 risks or barriers or things we need to explore. One is, of course, the technical, technological questions, and we are solving them pretty successfully now. Unfortunately, the supply chain is not ready, so we have to do quite a bit of stuff ourselves, and we are pretty much vertically integrated company, and we develop all the critical components ourselves. And we are successfully demonstrating it both on the ground, but also flying the aircraft. The second thing, which we already talked about today, is the regulatory landscape, and we are de-risking it by working very closely with 3 main civil aviation authorities. That is UKCAA, EASA, European Civil Aviation Authority, and of course FAA in the States. And it is interesting that the first time when we started to talk to them about hydrogen, it was about 5 years ago. Nobody knew about it. Okay. So now all these 3 civil aviation authorities are very heavily engaged with us, in particular in this journey. So we are talking to them, we are talking to their experts, and I think that we developed a path how to certify the engine and then the integration of the engine into the aircraft. And the last challenge or roadblock which we need to, of course, overcome is the infrastructure. The infrastructure is something which requires, of course, some of the CapEx. We need to invest money into it, and of course, we already demonstrated some miniature solution of how it can look like in other airports. For example, in our base in Cotswold, we are working out of Campbell Cotswold Airport in southwest England, and there we have our small electrolyzer, small compressor, we have storage, and of course our refueler. So which and of course we are using it airside. So now in parallel we are working on multiple different projects, both in the UK, in the States, and in Europe on bringing it to either to other regulatory environments and doing this with different airports, so that we and them get together the learnings of how to work with, with getting the permits, getting the safe operations, etc., etc. And this is, we are doing it as we speak.
Quite a lot of challenges to overcome though, and obviously you're working in the airport there as well, Lahiru. Anything you'd want to add on what you've been learning?
So I think, one of the big things is that there's a lot of positives and negatives. There's a lot of fragmented knowledge around. It's fragmented, but the knowledge is there. And I think for those for whom hydrogen and hydrogen safety and management is bread and butter, possibly underestimate how little everybody outside of that circle understands about it. But similar to Chris, what we had is when we've done work on the ground with hydrogen, we've actually reached out to bus companies, for example, and other operators who use hydrogen outside of aviation to understand those elements. And we have seen, especially our operators and so on, as in the individual operators, go through that transition of this is something that's new and scary, I'm suspicious of it, to I can treat this just like any other hazardous substance that I work with. Here's how we actually manage it and use it. One thing I did want to say about the infrastructure is, clearly there are big infrastructure requirements that will require CapEx. Now, that's true of, that's probably more true even for the start of this process than it is for the scaling up. But it is a journey, so while it is going to be difficult, one thing that we have to bear in mind is that the advantages are that we are starting small, so we're not going to need to have the tarmacs dug up at every airport in Europe for basic networks, and we can actually bring that in on wheels. Because the one thing that hydrogen does give us is it gives us the ability to tank a fuel with a very low weight penalty. So that is picking up the fuel for the round trip just at one location. So you're not having to refuel at the other end. Now, if you take jet fuel, you're having a 6-7% weight penalty and associated fuel burn emissions. With hydrogen, we're estimating more like 1%, and of course, no carbon emissions. So it changes the game in that sense. So we do have the opportunity there to start small, but with effective networks, and to build up those networks and to build up the infrastructure over time.
And then we need to scale things.
Well, that's part of the scaling.
Rebecca, what would you say about the challenges of scaling this process up?
Yeah, well, that's interesting what Sergey, you were saying about the supply chain, and that's a big part of what we're trying to work on with Hydrogen Innovation Initiative, is to understand what elements of that the UK can actually support and supply, which will obviously help with our own energy security and resilience. The more we can do in the UK, as well as it giving us that export opportunity, and from your point of view, having the reliability and that quality of supply and visibility of what that supply chain is. So there's a lot of UK industries that may not even know that they have something that could be a hydrogen version in the future, and that's another thing we're trying to see who is in industries that could pivot towards hydrogen, and making them aware of it and aware of and supporting them to do that, so that we keep manufacturing in other parts of the supply chain in the UK wherever possible.
Chris, are you seeing the same sort of transformation people change issues as Lahiru?
Definitely. I do think that even so, I've been with ULEMCo for 5 years now, and sort of moved into applications in the past couple of years. So it's only been sort of the past 2 or 3 years that I've been really attended events and things like that. And even within that time, you can see quite a change and much more acceptance of hydrogen, which is really nice. And I think part of that is down to big OEMs backing hydrogen as well. So when people see the likes of JCB, Cummins and things going out and spending time, money to make 100% hydrogen combustion engines and things like that, people I think are starting to realise now that it is a feasible option, and it will be something that's used in the future, so you can see much more acceptance.
Yeah, Lahiru, you're saying you can start small with this, but how do you move from that small to the big scale?
Well, it's really going to come down to the financials, right? Because what's going to happen is, the way we think of it, if you take this new technology, you've got 3 stages that go pretty much in a flywheel. So you've got the technology development, you've got the transition, and then you get to scale. And right now we're still in the technology development part of it, and that transition is going to be absolutely critical to, not even to scaling it fast, to whether or not we can scale it. And what has to happen there is that the early movers have to be able to adopt this technology. So if you take us as an example, we have to be able to make the case to our business and our shareholders to take the first aircraft, to be able to, and likewise the airports have to be able to do that for the hydrogen. That is a huge risk in terms of both the operational risk and the financial risk. So what is really critical to help drive that, to help take those first steps, is to bring in mechanisms to manage that risk and mitigate against that risk, because that is going to be absolutely critical to helping us take those tough decisions to take the first steps. Because if we don't take the first steps, we can't get any momentum going to scale it up.
Sergey, you're nodding along there.
Yeah, I think there are 2 aspects of scalability here, right? One is, of course, going from small aircraft to larger aircraft. Yeah. And the second aspect is to go from one airport to the network of the airports, right? So if we talk about the second, I think it's a challenge, but it's not as big challenge as for the ground transportation, right? That's the reason why ground passenger transportation on hydrogen didn't work, because it would compete with just like being able to recharge at every single light pole, or at thousands of gas stations here in the UK. Now we have about a few dozens of major airports here, and that number is manageable. Okay, so this is one aspect of scalability. The second aspect is to go from small aircraft to large aircraft, and I think that what helps us is that basically 2 things. One is the price of the engine is actually very similar, at least of our engine. What we are trying to achieve is that the price of our engine is similar to what the stock engine price would cost if you want to replace the engine, right? That's number 1. Number 2, in operations, it will be quite a bit cheaper because the maintenance costs are significantly smaller, because we don't have hot combustion processes inside of the turbine, for example, and instead we have the maximum temperatures, something like 100 degrees, in the whole powertrain. But also, on top of that, just the whole hydrogen scene is changing so much that the price of hydrogen is decreasing significantly. So maybe not now, but 5 years from now, we can see that it will decrease by let's say a factor of 2, if not more than that, and that brings even more benefits to hydrogen electric aviation.
So basically you're saying it's going to be cheaper and easier?
It is at least when we talk about what we see now in the next 5 years, we can see that we can deliver to our customers about 20 to 30% savings on operational costs. Now, of course, there is a caveat. We have to deal. Our business model is to work with the existing airframes, so we will retrofit existing airframes which are not designed for hydrogen. So of course, coming back, they occupying the storage occupies a bit more space. It is a bit heavier, so we will have penalty in terms of how many passengers we can carry. But what is the range of the mission we can achieve? So that is the penalty which we have to live with. But when we talk to our customers, we have about 2,000 engines on order, so they are ready to forgo some of the benefits of the jet fuel and live with these drawbacks of hydrogen electric for the time being.
What are you thinking, Chris?
It's obviously from an automotive perspective, it's slightly different. So one of the key barriers for the customers or our customers at the moment is the price of hydrogen, because they're not, although they're being pushed towards decarbonisation, most of our customers are choosing to make that change rather than necessarily having to. And what we find is they're choosing to essentially take on use of another fuel that is more expensive at the moment than diesel, but that is due to the lack of production in the UK and lack of availability. We'd expect, in the next few years that hydrogen will be much more cost competitive with diesel, but at the moment we're having to rely on customers who want to make that change and are willing to, incur extra costs to start that decarbonisation journey. So, at the moment, cost is still quite a big factor in the automotive side anyway.
And the HI is obviously working to address that, isn't it, Rebecca? But how are we going to make it happen faster?
Yes, and interestingly, the difference between the cost of hydrogen and to make it and the actual delivered cost to the customer, and that's also something we've been looking at, and particularly at the small scale, the things that are happening now with trials and even some like hydrogen generators and those kind of applications that people are trying to start the hydrogen economy in some ways, and they're struggling with the delivered cost of those smaller volumes, and there isn't really that marketplace for hydrogen as a commodity yet. So that's another area that we're looking at, because hopefully solving some of that, if that brings the cost of hydrogen down for all different applications, then that means more trials, more deployment, and it unlocks that hydrogen future.
Yeah, absolutely.
Obviously, but there's another session following this one that's going to be talking about investment, so that's a key part of the follow-on to how we scale these things up, Lahiru. But do you have anything that you want to add to that?
I think the reality of the fact that there has to be investment early on to make this happen, and if you're talking about it from the perspective of, I think, UK PLC, for example, there is a huge amount of potential. I do agree with Sergey that in the long run we do believe that this can be cheaper and easier for aviation and on the ground in aviation as well. But we need that upfront investment to be able to get the shove on to make it happen. And echoing what Chris was saying, we have seen huge potential on the ground with ground support equipment. All the manufacturers we speak to say, yeah, the hydrogen actually works really well for this. Problem is we can't get hold of enough of it, and because we can't get hold of it, it's expensive. So scaling up those early volumes, not aircraft volumes, but automotive level volumes, will do a huge amount to get things moving.
Sergey, anything you want to add to that?
So the way I look at this is that there is a lot of interest from different governments in hydrogen in particular, right? Because it comes not only with decarbonization of energy sector, but also with energy independence, which is kind of important in our world. I think that the price evolution of hydrogen will be probably similar to what we saw in wind and solar.
Yeah.
So the more investment, the more stimuli we have from the governments, and more target setting. I think that we will see the prices developing on the same trajectory as in renewable power generation.
So it seems like, just as we're about to move into an investment discussion, we're saying it's going to be easier, it's going to be cheaper, but we need the money now. Any counter to that, or is that where we leave the conversation?
Yeah, of course. No, I mean, we have supply and demand issue. Okay, yeah. So if we invest too much into production of hydrogen, but we have no demand, then the equation will not match, right? So therefore, we need to develop the technologies. We need to develop the use cases. We are working in aviation, of course, ground transportation. Different heavy to abate industries like cement, steel, of course, come on board as well. But I think that this is it costs money to develop the technology. So while we are investing now, we will reap the benefits in going forward.
Any final thoughts, Rebecca?
I think you were just about to.
I was just going to say, on we talked about the hard cash aspects of it, but the softer side that can help to drive demand is also making hydrogen mainstream, because right now it's seen as this slightly scary thing that can help us as a world to decarbonize. I think the more that hydrogen becomes normal and normalized, so there's a huge education piece that will help to accelerate the transition as well.
And I think that's where we come in more on the automotive side with the GSE that you mentioned before, so the ground support equipment. A lot of that is obviously vehicles, which falls right into ULEMCo's remit, and hopefully if we can start to look at that on the aviation side, it's only going to grow the demand, but also make the use of hydrogen more common in that area as well. So,
anything else, Rebecca?
I think the idea of people knowing how important hydrogen is, and the fact that it's already used in industries, people sometimes think of it as completely new, which it isn't, and that there are those places where it's needed more. Sometimes hear people saying that hydrogen obviously isn't going to work because they tried it with passenger cars and it's not working. It's like, well, that's a very, very small part of one use case that maybe isn't the most appropriate one for hydrogen in many cases. So there is that education about what the applications of hydrogen actually are today already, and how we need to decarbonise those, and then everything else that once you add all of those applications together, it is a really significant part of what we need to do to decarbonise.
So it's that systemic change. It's going to be cheaper and it's going to be easier, but we need the money. So that seems like a good place to hand over to Athanasios.